Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to start with the equation of a circle in general form, and we're going to try to rewrite it in center radius form, and once we can get into that form, then we can determine what the center and radius of the circle are. This is going to involve completing the square, and we're actually going to complete the square twice, once for x, once for y. The first thing that we need to do is subtract the constant to the other side of the equation so that we can group the terms containing x together, the terms containing y together, both on the same side, with the constant terms on the other side. So I'm going to rewrite that here, x squared minus 8x, and I'm going to leave a little space, plus y squared plus 10y, and I'm going to leave a little space so that we can add a number to complete the square, is equal to negative 32. Now, to complete the square for x, we take the coefficient of the x term, negative 8, we divide that by 2, and we square that. Negative 8 divided by 2 is negative 4, and negative 4 squared is positive 16. So I'm going to add 16 next to the terms containing x, and I'm going to add 16 on the right-hand side. Do the same thing for the terms containing y. The coefficient of the y term is 10, so we're going to be looking at 10 divided by 2 squared. 10 divided by 2 is 5. 5 squared is 25, so let's add 25 on the left and right sides. The first three terms are that's a perfect square trinomial. By adding half of that coefficient squared, we've made it into a perfect square trinomial. Think about how you would factor x squared minus 8x plus 16. It's x minus 4 times x minus 4, or x minus 4 squared. And that minus 4 and that negative 4, that's no accident. That value is always going to be in the factored form. For y squared plus 10y plus 25, that is y plus 5. Quantity squared. And on the right-hand side, negative 32 plus 16 plus 25, that equals positive 9. That value is r squared. So that tells me that r would equal the square root of 9, or 3. And my center is 4, negative 5. What's being subtracted from x? What's being subtracted from y? So the center of this equation is 4, negative 5, and the radius is 3. And if we needed to graph this equation, we'd plot a point at 4, negative 5, over 4, down 5, and then we would go 3 units left, right, up, and down, and then connect the dots, draw the circle that goes through them. The next problem is a little more challenging. We've got 4x squared minus 16x plus 4y squared plus 12y equals negative 75. And we're going to start the same way by adding 75 to isolate the constant on the right-hand side of the equation. So 4x squared minus 16x plus 4y squared minus 12y equals 75. By the way, the coefficient of x squared and y squared, those need to be the same as each other, but they don't necessarily have to be equal to 1 like they were in the first example. So here, to complete the square, I need to factor out the common factor first, and the common factor for the first two terms is 4. 4 times x squared minus 4x, and I'm going to close some parentheses there, but I'm leaving a space so that I can complete the square. I'll do the same with y. Factor out the common factor of 4. That's y squared minus 3y. Leave some space, and that's equal to 75. Complete the square for x first. Negative 4 divided by 2 is negative 2, and then we square that to get a positive 4. So I'm going to add 4 into the parentheses with the terms containing x. However, I've really got 4 times 4 on that left-hand side, So on the right-hand side, I have to add 4 times 4. For y, it's a little trickier because that's an odd number. Negative 3 over 2 squared is 9/4. So I'm going to add 9/4 in the parentheses containing the terms with y. And on the right-hand side, I've got 4 times 9/4, because again, I've got that 4 as a factor in front of the parentheses. The first one factors pretty easily. X squared minus 4x plus 4, that is, x minus 2, quantity squared, plus 4 times something squared involving y. Remember that number, when we take the coefficient for y and we divide it by 2, that number is going to show up in the factoring. Oh, I've made a sign mistake here. It's unfortunate to have caught it here. I made a mistake. Let me put some red on that. It was plus 12y, but I had written minus 12y. When I factor out the 4, that's going to be plus 3y there. So I think I've edited it correctly. Where I am fortunate is that positive 3/2 squared is still 9/4. So I've added the right number there, but I'm glad I caught that when I did. It's not about whether you make mistakes or not. It's, do you realize that you've made a mistake and can you fix it at that point? All right, so back to what I was saying before I caught my mistake. The 3/2, that positive 3/2, that's going to be part of the factored form. So it's going to be y plus 3/2 quantity squared equals, and let's see what we've got. We've got 75 plus 4 times 4 is 16 plus 4 times 9/4. The 4s we can divide out, and we're left with just 9. Let's write this again on the next line. 4 times x minus 2 squared plus 4 times y plus 3/2 squared equals 75 plus 16 plus 9 adds up to be 100. This is still not in the correct form. Remember the correct form, let me scroll to the top of the page, right? It's x minus h quantity squared, not some number times that. I've got to get rid of the 4 that's in front of those square terms, and I can do that by dividing. I'm going to divide all terms on both sides by 4. So now I have x minus 2 quantity squared plus y plus 3/2 quantity squared equals 25, because 100 divided by 4 is 25. For the center, 2 comma negative 3/2. What's being subtracted from x? 2. What's being subtracted from y? Y minus negative 3/2 is the same as y plus 3/2. Another way you can think about it is, what value would I have to plug in for x and for y to make that expression 0? 2 minus 2 is 0. Negative 3/2 plus 3/2 is 0. That might help you to find it a little better. I know that 25 is the square of the radius, so r is the square root of 25, which is 5. The radius here is 5. And again, once we have it in that form, not only do we know the center and radius, but we know how to graph it. We would put a point at the center, and then up, right, left, down by a distance of 5, and then connect the dots. All right, we'll do one application involving circles in the next video.